Saxon Advanced Mathematics, Lesson 97. Welcome, students, to Life After Spring Break. Let's take a look at where we are before we dive into 97. Dun, da, da, da. Oh gosh, I've got a lot of catching up to do. We have already reviewed for the midterm. We have taken the midterm. And sadly, we have completed our spring break as well. For me, it is Sunday, April 11th. So I'm wrapping up my spring break by talking to you. You are probably on Monday, April 12th. You have no homework due today because I don't assign homework over the breaks. So on the Monday after a break, you don't have anything due. You just show up and start doing the new lessons. Next week, your homework will be due for the lessons that we're studying this week. But you don't have any homework due today. Yay. Excuse me. In just a minute, I'm going to launch into 97, and we're going to cover the 4 lessons this week. That will get us done through 100, which is a really fabulous goal for us. Then what we are going to do is not these lessons, because we are going to focus on preparing you for the AccuPlacer. And what that means is that we're going to work the 10 key to algebra booklets. That's going to be super strong review that is going to get you a super, super thorough refresher on all of the things that you've forgotten because you've been doing much harder things. And then we're also going to do some sample test questions. And that's going to prepare you to take the AccuPlacer, to place into college level math, and it's all going to be glorious. If you have not already done so, please watch the half-hour video that I created for you and your parents. It's on my YouTube channel, but I also sent you a link, and you'll freak out because it's not my hand on a piece of paper, it's my actual face in a video. So that reminds you of what this decision is. But we will not be doing this because we're switching gears and we're getting into this process. I will talk to you more about it when we have our video chat at our regular time. You guys are all... No, Vivian talks to me on Thursday. So that'll be Thursday the 15th. Jayla and Laura, I'll talk to you on Friday the 16th. And we'll get transitioned into this. But this week is a standard week. So here's Lesson 97. Lesson 97 is about something we've already talked about, the ambiguous case. We know that we can use the law of sines to solve for missing parts, right? There's 6 parts of a triangle, 3 angles and 3 sides. We can use the law of sines to solve for missing parts, but if we have an angle and a side plus one other side, we get this ambiguous thing, right? Where the angle could be one of 2 angles. We've dealt with that. And what we have done is we've relied on the drawing, the diagram of the triangle, to help us ascertain, is this a less than 90 degree or a greater than 90 degree angle, right? We've relied on the diagram. To resolve the angles, right? Well, notice that's in the past tense. Today, what we're going to do is deal with the law of sines and the ambiguous case when we don't have a diagram. We're going to come up with a way to resolve these problems. All right, so we're going to be given this scenario, and let's just dive in. Example 97.1. We're given an angle and a pair of sides. And remember that angles have upper cases and sides generally have lower cases, and they pair, right? This angle is going to be opposite this side. That helps us draw the triangle a little bit, okay? So what we're going to assume is that these 2 are a pair, and as we often do, we're going to assume this is the hypotenuse. Okay? And even if this was a different letter, this is kind of Pythagorean style hypotenuse, we're always going to assume that the additional side is the hypotenuse. So the first thing that we do is consider this as if it were a right triangle. Okay? So we don't know that it's a right triangle, but we're just going to start with that assumption. So that would look like this. And I'm guessing at some of these lengths, but we know this is a 40-degree angle. This is going to be A. Over here, we know that this is 4. And then we're going to call this the hypotenuse, so we're going to call that 9. Okay? This is not necessarily what's right. I'm just making that assumption to start. Now, what we're going to do is we're going to calculate H. That's the height of the triangle, right? We're going to calculate this distance, which is we're going to calculate the height as if it were a right triangle, and then we're going to compare this value to our A value. Okay, so how do we calculate the 8? Oh, well, we can just use sine, right? Oscar had. So we know that the sine, this is so basic, it's probably hard for you. The sine of 40 degrees equals H, because we're assuming, we're not relying on A right now. We're just calling this H because we don't know that that's our triangle. We're just considering this to be. You might even say assume. Okay? And then our hypotenuse is 9. So remember, we do this. We say 9 times the sine of 40 degrees equals H. And that gives us a value, using calculator, of H equals 5.79. Okay. Now, we can use, so that was our first step. Our second step was calculated. Now, our third step, compare H to A. Okay? Now, if H is greater than A, then there's no triangle. Because that's just bothering me. Because H is kind of the minimum value that this can be, right? If this were an angle like this, H would be, this value would be longer, right? A right triangle creates the shortest value for this side because it's straight down, right? Anything else is going to be at an angle. It's going to be a longer value. So if H is less than A, then it's not possible for there to be a triangle. And John draws that like this, right? Pretend that's straight. Right? Because if A is less than H, then it's not going to go all the way down, right? This would be the length of H. So if H is greater than A, then there's no triangle possible. And that is the case in our scenario because H is 5.79 and A is 4. So because 5.79 is greater than 4, then we know there is no triangle possible. And that's the answer to this problem. Now, this is helpful in illustrating that scenario, but what if it isn't? What if A is greater than H? Then how do we decide what to do about that? That's the next problem. But I want you to be very clear that what we do first is that we assume it's a right triangle. We call this distance h because we want to calculate a value and then compare it back to our a value. And we do that very easily. And then we know the first scenario. If h is greater than a, then it's not possible to have a triangle. No solution. Okay, let's try b, and I'll give you spoilers right now. This time there will be a triangle possible. And there's only these two. Okay, draw the triangle and find the missing parts if a equals 27. Okay, so again, I'll say assume this time. We assume it's a right triangle. Okay? So I always like to draw it like this because it makes me most comfortable. 27 degrees goes there. Our A value is going to be over here, but I'm not going to put that in. I'm just going to call that H. And then we always use this as our hypotenuse value. So H will be equal to 7 times the sine of 27 degrees. I'm just jumping into it this time because in the first example I showed you, I reviewed for you the bit by bit way that we calculate that. But we've been doing this calculation for a long, long time. The hypotenuse will be equal to the sine times H stands for height, not hypotenuse. This side will be equal to the hypotenuse times that. And that value so this was our step 2. Calculate H and compare to A. Okay, so this time we see that A is greater than H. Yay, that means we have a triangle. That's good. But we have to do a little bit better. We have to find out more than that. There's 2 possible scenarios. It could be a triangle like this, right? Where it's 7, and now we can use our A value because we know that it's longer than H, so that's good. And then this would be 27 degrees. It could be like that, or, so this is step 3. I lumped, in the last problem, I made this into 2 steps. I don't really remember how I did that, but I'm kind of rearranging my steps, but I'm adding to it. So it could be this kind of an angle, or it could be like this, right? Okay, we don't know yet which one it is. So what we need to do is here's the thing. It could be both of these. So what we have to do is find the missing parts for both of them. Okay, so I'm going to call this option A and this option B. If option A, we have to find all the parts for both of them is basically what we have to do. Because they're both possibilities and we're not going to be able to rule them out. So what we're going to do is use the law of sines. Don't think we have to do anything else. That's the tool we'll use for both of them. Okay, so let's consider this first scenario. We want to find angle B. This is A, this is B. Okay, so we know that 5 over the sine of 27 degrees will equal 7 over the sine of B degrees. All right? Then we rearrange. I'll cross multiply And when I do, I'll get the sine of B equals 7 times the sine of 27 degrees over this, over 5. And that, first we simplify this, and then we use inverse to get this, and our angle B will be either 39.46 degrees or 140.54 degrees. Okay, now we see, all right, what we've done is helpful. This angle is the 104.54, right? Oh, I'm sorry, it's 140. Okay, so we'll use the fatty angle up here. This is the fatty picture. And then down here, we'll use the smaller one. So we're building a triangle for each of the ambiguous cases because we don't know which it is. Okay, so we have to consider both of them. And then we can easily calculate our angle C. How am I going to do this? I'm going to recopy these triangles here. Okay. So this one we had, this was 140.54. And this was 27. And this was 7. And this is 5. That's A. Okay. So this was our obtuse triangle. We just calculated this as the larger of our two law of sines value for angle B. And now we can easily calculate C just by subtracting 12.46 degrees, right? These three add up to 180. And now we'll use this to find side C, which is down here. And we'll say that we'll take our usual 5 over the sine of 27 degrees equals C, side C, over the sine of 12.46 degrees. We'll use this angle value to find that one. And again, we'll cross multiply and divide to get C by itself. C equals 5 times the sine of 146. I'm having a hard time with my numbers today, which is a terrible thing for a math teacher to say. 12.46 divided by sine of 27. That's just cross multiplying. And then I run this through the calculator and I get that the side C length is 2.38. Okay, so now I have filled in all the missing pieces. Again, we use the law of sines as our tool. For the angle, we could just subtract from 180. Okay, so now we have completed this as one triangle that solves the criteria that our problem set out. We'll never eliminate the other possibility, so I have to draw that one too. We were working on it before. Okay, this was 27 degrees. This we knew was 5 and 7. And when we calculated this value for B, we found that the other value for B could be 39.46. So we'll now draw that triangle, okay? And we use the very same steps to make it work. If this is A, then we know that C will be equal to 180 minus that and that, which gives us 113.54. Okay, so coming up with the third angle is easy. Now we need to come up with the third side. We could, if we wanted, do a squared plus b squared equals c squared, but let's do it using the law of sines because that gives us a precise decimal answer. And we'll use the law of sines to do it. And again, we'll use 5 over the sine of 27. That's a 5. Equals little c, this side, over the sine of 113.54 degrees. Okay? Cross multiply and divide away. We get c equals 5 times the sine of 113. Okay, calculator work, we get C equals 10.10, 10.10, not 10.10. So that is this. Okay, so we've done the same thing. We found all 6 pieces, okay? So without a diagram, we can never narrow down to exactly which triangle we're finding, but we use our same tools and we just create both triangles, okay? So just to remind you, in this case, we calculated the H value. We found that H was larger than A, which means, oh no, that was the same problem, this one. If this height is larger than our A value, then it's not possible for there to be a triangle. We basically have a situation like that, right? But if A is larger than H, that means we have a triangle. In fact, we have 2. Because we can never eliminate one of those. We just have to consider both options, okay? Before, when we got to this point, we used our picture to eliminate one or the other, but here we just say, I don't know, it's gotta be one or the other. Okay. I hope this makes sense. What I want you to take away from this lesson is that we're using our trig tools, our basic trig functions, and the law of sines. We're using those to solve more complex problems. And so what I want you to take away from this is that these tools have many applications in the real world. This is a very real world-ish problem where you could be trying to find these values. And we can use the tools to solve lots of different problems. Yay! 97 is done. We are well on our way to completing this last week of John. I am wiping a tear. I don't know about you. It's a very emotional time for me. Okay, that's the end of 97. Thank you. Goodbye.